Dear students, welcome to this session. In today's session, we are going to look into the next lab program number 1, lab program number 6. Lab program number 6, the problem statement is introduce one-dimensional, 1D is one-dimensional array manipulation and implement binary search. So we are going to do 1D array manipulation and we are going to implement the binary search. So there are two things about this program. One thing is the knowledge about the arrays. I hope this array topic is already it is covered in the your theory class. What is an array? Array is a collection of similar items. So if you have similar items, let's say you have you want to store a set of integers. For example, the marks you have scored in respective subjects. Let's say you have 5 subjects. The marks scored in each of these subjects, it is a group. So the all the marks are a particular group. So if you want to store that group of marks in an array, you can do so using an array data type. So array can be used to store a similar kind of or a similar items having a similar data type. So if you want to have a collection of items of integer type, then it is possible. Then all the items in that particular array would be integers only, and then you define that array, you declare that array as an integer array. And if you want to have a array of floating point numbers, you can do so. You can create an array of data type float, which will hold all the elements of float data type only. Similarly, you can create an array of all the characters, which we already saw one example in the previous electricity bill, where the customer name is, it is the combination of characters. So we store it as an array of character. So the name was a character. So name was a string, it is a collection of characters. Now when you declare a array, the array has to we have to declare first what data type we are going to store, and second thing we should tell the compiler is how many elements we are going to store. The collection will have 50 elements or 100 elements. That size has to be told to the compiler when we do the declaration. That is a one requirement. And once you have the array declared, you can store if it is an integer type, you can store integer into each of those array elements. And how you can access those array elements? You can access those array elements using a index. So if you have an array of size 50, here you can say array of size 50. This array, name of this array, so this is array of size 50 and it is of type integer. What is the meaning of this? Is the name of the array is A. It can hold maximum of 50 integer type data elements. So this can hold 50 integer data elements. And how we are going to access each of those 50 elements? We are going to access using the index a of 0, a of 1, a of 2, a of 3, so on until n minus 1. That is, the last element in this particular array would be a bracket square bracket 49. That will give us the last element. That is how we access. So just I will show you the diagram here, which I have already drawn. Let's say we will remove this part. We will talk about that later. Okay. So we have an array of size n. So array of size n. Now array called A. The name of the array is A. When you do this declaration, the declaration here int a of 50. So when you do the declaration like this, int a square bracket, and you mention the integer constant, always integer constant, and semicolon. So this is what declaration of the array. When you do this declaration, what is the meaning of that? You have created a continuous memory location which is called as an array, and its name is a, and it can store 50 elements. So in this case, this would be n minus 1. It can store 0 to 49 index, and it can store 50 elements. So we can have a of 0, a of 1, a of 2, a of 3, so on until a of 49. All together it would be total 50 elements. And what number I can store here? Any integer number, let's say 45 or 10 or 6, any number I can store here. And how do we access this 45? If I say how do we access 45? If I say a of 0, then this is nothing but a of 0, this is nothing but 45. If I want to access a of 6, I would say a of 2. A of 2 would be 6. Okay, value 6. So this is how you can access. So now you can use this a of square bracket you are going to use, and you are going to use the index, and this can be used similar to any other variable. So for your seen variables, single variable, if I say like int space x, how you are going to use x? You can say x is equal to, you can say x is equal to 50. That is how you assign, and you want to use that x in some calculation. Y is equal to x into 25 plus some other operation. So you want to do some other operation. So in the any arithmetic operation, you are using this value of x. The index, the array also can be used in the similar fashion. Suppose instead of having these values, let's say in this index location 2 I want to place a number, or in index location 3 I want to place number, let's say 25. I would say a square bracket index is 3. So this index is 3 is equal to, I will say 25. The minute you do this assignment operation, number 25 will be stored in this location. And let's say you want to use this in any calculation, then you can say y is equal to a of a square bracket index 3 multiplied by 2. So what this operation will do, a of 3, a of 3 is nothing but 25, 25 into 2, 50, 50 will be stored in y. So you can use this array in very similar to the regular variables. Okay, I hope it is clear. This is just a revision from apart from what it has been done in your class. Now we will go back to the problem statement. So that is the array manipulation. So this is how you reading the array. How we read the array? Because it is a collection, we are going to read one element at a time using the for loop. You must already know, if I want to read a single one dimensional array, I will use one for loop, and for loop will start with index of 0 and it will go until n minus 1, and we will use the scanf in the for loop, and we are going to read every element. Okay, that is how array manipulation. Next is implement binary search. First is binary search is a one searching technique. So for your syllabus there is a linear search as well as a binary search. Linear search is important question from the theory perspective as well. So for lab you have binary search. In case of a binary search, searching is a technique. So we suppose we have certain number, okay, we call it as a key, and we are trying to search whether this number, whatever the number, user given number, it is available in the set of numbers, that is given array. My given array, I am going to store n number of elements, and user will give me one particular number. When user gives one particular number, I will search whether that particular number is present in that list of array. So the simple technique is linear search. In case of, if you remember linear search, what we did, we take whatever the number given by the user, that is the key which I want to find whether it is present in the array list or not. I will keep on searching. I will first compare it with a 0 location. If whether it is let's say user give me some, I will delete this part. Okay, let's say user give me a key, some key value users will give. Let's say he gives 33. So simple technique is what, I will check 33 whether it equals to the number, first number which is at location 0. Now it is not equal. Then I will move on to the next index location. I will compare 33 is equal to 10. No. Then I will move on to next index location, whether 33 is equal to 6. No. And then I will move on to the next location, whether 33 is equal to 25. No. So I will keep on increasing the index location, and I will do the comparison of key with the value of the array element, and I will keep on doing until the last array element. And if I don't find, then I will say the search key, whatever the user has given 33, is not present in this list. Let's say user give me a key, for example I will take the key as 25. User has given me 25. Again I will start from the beginning with a 0 index location. I will compare 25 with a 0 index location. 25 equals to 45. No. I will move on to, when answer is no, I will move on to the next item, next index location, until I reach the end. So in the next location 10 value is there, whether 25 is equal to 10. No. I will move to the next index location 2. 25 is equal to 6. No. Again I will move to the next location, index location 3. 25 is equal to 25. True. So we found user given key is available in the index location 3. So we will then we will say the user given key is present in our array or a list of numbers, and we say the search key is found. So whatever user given number, it is found in this list of numbers. So this is the simple technique what we discuss right now. It is called as a linear search. Okay. So what we have for the lab program is another technique, binary search. In case of a binary search, what we are going to do is we are just going to divide this, and linear search will go element by element. So it will start from the 0 and it will keep on checking with, if you have a array size of let's say 1000 items, then your linear search will make 1000 comparisons. Binary search will reduce. So binary search, what it will do is it will break the search array into half, and that is the one technique that is used. It will check whether it is equal to the middle element. If it is equal, we will directly send this is present. If it is not equal, we will check whether it is greater or less than. And one condition for the array element is all these elements should be in the ascending order. We cannot have a random number. How we can have these numbers is in the ascending order. So it should be like 6 should be here, okay, then 25, and then say let's say 40 or whatever the number we had. So this search should be always in the ascending order. When user gives the a certain number to be searched, first we will check with the middle number. If it is equal, then we will give that index location as the location of the search, and if it is not equal, then we will check whether the given number is less than or greater than. If it is less than, then we will only search in the left half. If it is greater, then we will only search in the second half. That is how we are dividing the whole search into half. That is the binary. Binary is a like either this side or that side. So that is how we are dividing, and that is how we are reducing number of comparisons before we find the actual number is present or not. So we are reducing the number of comparison in this algorithm. Okay, so that is the problem statement. I hope you understood the problem statement. So introducing a 1D array manipulation and implement binary search, that is the task for us, and we are going to write a program. So let us start with the program. Hash include stdio.h, this is the standard library we have to include, and this is going to be the first statement of all our program. And then we are going to write the main method, main and a pair of parenthesis, empty parenthesis. After that we have open curly brace, and this is the start of the program. And if you go exactly bottom, this is the closing curly brace, that is the end of the program. So that is the minimum requirement for any program. We all already understood about that. Now see, we have declared a couple of variables here. First one is all are integer. We are using all integer values. First we have declared an array. Array name is A, and how many elements it can hold? It can hold 50 elements. This array A can hold 50 elements, and its index will be from 0 to 49. And we have a variable called n. What is n? N is how many values users want to enter in the array A. Okay, users may not want to enter all the 50, he just wants to enter 10, then he will give the n value as a 10. And we use one more variable called as a low. So it is indicating the lower value of the index. And one more variable mid, mid. Mid will indicate to the middle location, middle index location. And high, high, high will is the variable which will point to the highest index location. We will see how we are going to use it, just these are variables for now. And what is key? Key is the number which user will give, which he wants to search in the array. He will check whether this key is present in this array or not. And next is I is just one variable we are going to use for looping. Any variable you can use. And I am going to use the flag. The flag is the variable. Initially it is set to 0, and if I find a particular key is present in this array, I will make the flag as 1, otherwise it is 0. So at the end of the program, the flag value remains 0. That means there is no match, means the search key, this search key is not present in the array A. If this flag becomes 1, then that particular key is present in the array. Okay, let's start with the program. First is just will display for the user, enter the size of the array, means how many elements user wants to enter for this array. So maximum you can see is we can have maximum 50, not more than 50. If you want to take more numbers, you have to increase this. Just for the programming purpose, maximum limit is 50. When we are declaring, we are telling the maximum number or the elements this array can store is 50, but we don't want to use all the 50 memory locations. We will ask user how many he wants to enter. Let's say enter the size of the array. Let's say user wants to enter 5 numbers. User will give 5. So scanf, this is the syntax for reading the number. Scanf, open parenthesis, inside the double quote %d, because n is the integer, comma, ampersand n, closing parenthesis and semicolon. Ampersand should be preceded before any variable in case of a scanf function. After that, once we read the size of the array, then enter array elements in ascending order. It is very, very important. The array should hold all the numbers in the ascending order. And how to read an array? Ampersand a bracket square bracket of I. So how many elements it can store? Let's say user gives this number as 5. So the array can hold 5 numbers. So we have to read 5 numbers from the user. And how I am going to read 5 numbers from the user? It is using the for loop. One thing you remember, when we are reading one dimensional array, we use one for loop. Okay, and that for loop will start from 0 and it will go until n minus 1. So for I is equal to 0, that is the initial value, I less than n means I less than 5, I plus plus, and only one statement is in the for loop, scanf %d and ampersand of a of I. This is how we read the array elements. Let's say initially I is 0, then ampersand a of 0. So whatever the user gives first number, that will be stored in the first location. So if I remove this, so this is how the array looks like. When for loops starts, I is equal to 0, let's say user gives as 10. So that 10 value will be stored, and I value will, once this reading is complete, I value is incremented to 1. I will become from 0 it will become 1, and 1 is less than 5, true. Again scanf %d a of 1. So whatever the number user gives, that will go in the next location 20. And after this is done, array will increase to the index will increase to 2, that is I plus plus, it will increase to 2, 2 less than 5, true. Again scanf, it will read ampersand a of 2. So 2, let's say user gives 30, and that 30 is stored in a of 2, and after that the statement is complete, it will go to the increment, I will become 3, then 3 less than 5 is true, a of 3, a of 3 will read, and let's say user gives the number as 40, and it will store that 40 number in location number 3. Then what happens, array I value is 3, it will increment to 4, 4 less than 5, true. It will come scanf ampersand a of 4, let's say user gives 50, so this is location is 4 and user gives the value as 50, and we do not have other columns, just I will delete that, because user has given the array size as 5, only 5. So array size here, this is array size n is equal to 5. So this is how it looks when it completes this for loop. I hope you understood. First user will give, he wants to enter 5 elements. After that we have a for loop reading one element at a time, 0, 1, 2, 3, 4. Okay, so what we left is when index becomes 4, again it will increment 4 plus 1, 5, 5 less than 5, false, it will come to the next. So it will not go beyond this, already it has read 5 elements, 1, 2, 3, 4, 5. So index would be 0 to n minus 1, that is 5 minus 1 is equal to 4. Now next statement, enter search key. So user wants to search a particular value that he will give. Let's say user will give the some value as 33, that 33 is stored in key. So the key will have the value, as 33. Okay, so this is the number. Now what is the task? We have to check this 33 is present in this array or not, and we have to use binary search technique. If this array, this number is present, we will display key is present at certain location. If this is not, then the search key is not present. In this particular case, this is not present, so what would be the output? The key is not present. Let's say user had given this value as instead of 33 he had given it as 30, then the key is present at index location 2, that is the output of the program. Next, so next what we will do is we will initialize the low to 0. So we set low is equal to 0, means the low will indicate to the lowest location 0, and high will indicate to the HIGH will indicate to the highest location. And you can go back, what is high is equal to n minus 1, we have taken n as 5, 5 minus 1, that will become as 4. After these two statements are executed, low is equal to 0, high is equal to 4, means low is pointing to the first element, high is pointing to the last element. Then inside from here to here it is a while loop. So this is the complete implementation of the binary. This is called as the heart of your program. So what is the technique in binary search? In case of a binary search, we check that key is present in the middle location. Okay, this key is present in middle location. If it is present in the middle location, we will send that we will return that value of the index saying that this key is present. Let's say this key is not present at the, so possibility is either it is equals to the middle value or not. If it is not equal to the middle value, either it is less than or greater than the that particular value. So let's say user given value is less than the middle value, so this value will fall somewhere this side. If this key is greater than the middle value, then that value will fall on this side of the array. So that is how if this number is, let's say I will take, for simplicity I will take 20. Initially when you compare with the middle value, it is not same as the middle value. Then we will check whether this given number is less than the middle value. If answer is true, then I am going to search on the only the middle side of the array. And there is another possible one, is the key can be less than the middle value or key can be greater than the middle value. If a user gives the key as 40, now this 40 is greater than the middle value, so this value will fall on the right side of the middle value. So I am going to search only this side. So that is the logic that is used. Now we will see, first we will check low is less than equal to high. So what is the low? Low is 0, high is 4. Okay, low is 0 and high is 4. And once we come that, we calculate the middle value. What is the mid? So first I will do is I will say this is while loop. I will say this as while loop, and I will say iteration 1, means while loop first time. First what okay, I will take after this. And little bit upwards I will take. Okay, so we have a array 10, 20, 30, 40, 50, and user has given a let's say we will begin with the key of user has given 30. Okay, user has given 30, and after that we did the initialization. Low is equal to 0, high is equal to n minus 1, high is equal to n minus 5 minus 1, 4, high, that is the high value. So while loop condition is checked. Low is less than equal to high. Low is 0 and high is 4. 0 is less than equal to 4, answer is true. Then what we will do, we will calculate mid. Mid is equal to low plus high divided by 2. So what would be the value? So this is the while loop number 1. Mid is equal to what? Low plus high divided by 2. 0 plus 4 divided by 2. 4 divided by 2, we get it as 2. Now next, what is the next? We have, there are 3 if condition. One is checking for the equality, one for less than, one for greater than. Let us check what is the value of the key. Key is given as 30. 30 equals to a of mid. What is a of mid? Mid is 2. A of 2 is 30. So what is the answer here? 30. This key is 30, whether it is equal to a of 2. And what is a of 2? A of 2 is 30. So 30 equals to 30. That means the answer is, this condition is true. It will come inside here. What it will do? It will say flag is equal to 1. What is the meaning of flag is equal to 1? It found this key. So whatever the user given key, it was available at the middle location. It found it, and after this it will call the break statement. And you must be already aware the break statement, what it will do, it will break the while loop. Once we find the key at a particular location, we set the flag is equal to 1 and we execute the break statement. When we execute the break statement, this while loop is broken and the instruction execution will move from, once it executes this break, the execution will directly come out of the loop. It will break this loop, the execution will come here, okay, outside the loop. So this is inside the loop. These two curly braces mark the loop of the while loop. The execution will come here. Then we will check if flag is equal to 1. So already we set the flag is equal to 1 because we found the search. Flag is equal to 1. Printf, the search key %d is present at index location %d, means the search key %d is replaced by key. So the search key 30 is present at index location, what is the mid value, 2, index location 2. That is what is printed. And if this condition is false after all the looping, we say the search key is not present. So we just looked into the first case, okay. It will directly come out if it is key is present at the mid location. Let's say a user has given some other value, let's say I will say 32, okay. User first I will take all the positive scenarios and then we will go for the negative scenarios, okay. Positive scenario in the sense what, the search whatever user given key is available in the array, okay. After that we will go for the not available, search key is not available. Let's say user gives the key as a 20, okay. User gives the key as 20 and once user let's say we run the program again, and again user will give 10, 20, 30, 40, 50. Key search key is now 20. Low is equal to 0, high is equal to 4. That will remain same because only 5 elements are there. Then we come inside the loop here. 0 less than equal to 4, true. We calculate the middle value. 0 plus 4 divided by 2 is 2. Now key, what is the value of the key now? Key is 20. Mid is calculated as 2. Now key is 20. 20 equals to a of 2. So a of mid is a of 2. A of 2 is 30. 20 equals to 30, false, okay. So the code will not come inside here. So once it is false, there is no else statement. It will check the next next condition. There is no else condition. Once this condition is false, the execution will come here. It will check if key is less than a of mid. What is the mid value? 2. Key is 20. 20 is less than a of 2. Let's see. 20 is less than a of 2. A of 2 is 30. So 20 less than 30. It is true. So if this condition is true, 20 is less than 30 is true, high is set to mid minus 1. So what is the meaning of this? Key less than 30 means the key will lie on the left hand side of the array. So the that is the meaning. So the low value will remain same. Now instead of searching the high value is 4, instead of searching here we should bring that high to here. So instead of going 30, this is not equal, and the key is less than 30 means that value is somewhere on this side. So low would be 0 and high would be mid minus 1. That is what we do. So when key is less than a of mid, when 20 less than 30, high value I am making mid minus 1. What is mid? 2. 2 minus 1 is 1. So I am making high as 1, isn't it? So high value become 1. Now after that it will come to this statement. If key is greater than 20 greater than 30, false. So it will not go here. and it will go for the next iteration of the while loop. So now we are in the next number 2 iteration of the while loop. So now what happens, again the mid value is calculated. Now what is the value of low? Low is 0, it did not change. Low is did not change, but high value got changed because key was less than 30. This value got changed, and what was the new value? High, this is high is equal to mid minus 2 minus 1, high value has become 1. Now what is mid? Mid is equal to 0 plus 1 divided by 2. What is 0 plus 1? 1 divided by 2. This is an integer division. 0.5, 0.5 is discarded. So what is the value we get? Mid will be set as 0. Mid will become 0. And what is the next statement? Next statement is again this. Key is 20. 20 equals to A of mid. Mid is 0 now. Mid is 0. And now the question is 20 equals to A of 0. A of 0 is 10. Whether 20 equals to 10? False. Okay. So it will not go inside here. Then it will come here. Now 20 less than A of 0. What is A of 0? A of 0 is 10. 20 less than 10? False. So it will not go here. Now next condition. 20 greater than 10? True. 20 is greater than 10. 20 is greater than 10. It is true. Now what is the low? Low will be changed. Low value will be changed. Low is equal to mid plus 1. What is mid? Mid is 0. 0 plus 1 is 1. So low value becomes 1. Okay, after the iteration number 2. Now after this, it will come to the next loop, that is the third iteration. Now what is the value of low and high? Low is 1, high is 1. So when we come inside the loop here, mid is calculated again. Mid is equal to low is 1, high is 1. 1 plus 1, 2. 2 divided by 2 is 2 divided by 2 is 1. So what would be the value of mid? Mid value would be 1. So I would say mid value is equal to 1. Now again 3 conditions are checked. Now key, what is the value of key now? 20. Key will not change. We are not changing the what user wants to search. 20 equals to A of 1. And what is A of 1? A of 1 is 20. 20 equals to 20. True. Okay. 20 equals to 20. True. It will come inside here, and we set flag is equal to 1. After setting the flag, we say break. No more going into the loop. It will break it. So where the execution will come? It will come after the while loop. So if you see, after this while loop, execution will come here, and flag value is 1. 1 is equal to 1. True. The search key 20. Now key is 20 is present at index location mid. What is the value of the mid? Mid is 1. So we found the 20 at index location 1. That is what it will be displayed. So this is the second case. First case we took value as 30. So it matched at the mid location. We then took the key as 20. So it matched at the lower end. Now we will take at the upper end. Let's take 50. Okay, we will take the next iteration. User will give the answer key as 50. Okay, we will run the program again. So I will just delete all these things so that we can start again. Let these numbers be there. I hope that it will go into minimum 3 loop. So whatever the loop will go. Okay, so now user has given 50. Low is 0, high is 4. It will not change. It will come inside the loop for the first time. Mid is equal to 0 plus 4 divided by 2. 4 divided by 2, that is 2. Mid is equal to 2. And after that, it will check key. What is the key now? Key is user has given 50. 50 equals A of 2. A of 2 is 30. 50 equals to 30. 50 equals to 30. False. So it will not come here. It will go to the next. 50 less than A of 2. A of 2 is 30. 50 less than 30, false. 50 is not less than 30, so it will come to the next condition here. So it will not go here, it will come to the next instance. 50 greater than a of 2. What is a of 2? 30. 50 greater than 30, yes, 50 is greater than 30, true. Low is equal to mid plus 1. Okay, low is equal to mid plus 1. What is mid value? Mid value is 2. 2 plus 1 is 3. Now you can see we know that user given value is higher than the middle value. That's why we increased. Low was 0. We increased that value to 3 here, right? We are going to search only the upper part of the array. So that is how we reduced so many comparisons. Now low is equal to 3. Then again same, it will after this it will go for the next loop. So it will go for the next loop. Now we calculate the this condition again, this calculation again. Mid is equal to low plus high divided by 2. What is low? Low is 3, new value. 3 plus 4, 7 divided by 2. 7 divided by 2 is 3.5. 0.5 we are going to discard because it is a integer division. What we left with the 3. The mid value will become 3 now. Mid value becomes is equal to 3. Now next it will come here. Key is 50. 50 is equal to a of 3. Let us see what is a of 3. A of 3 is 40. 50 is equal to 40, false. So this condition is false, it will not go here. Next, 50 less than 40. A of 3. A of 3 is 40. 50 less than 40, false. 50 greater than 40, yes, true. This condition is true. 50 is greater than 40. Low is equal to mid plus 1. So low is equal to mid plus 1. We say low is equal to mid. What is the value of the mid? Mid value is 3. 3 plus 1 is 4. Okay, 3 plus 1 is 4. After this is complete, it will go for the next iteration. Now what is the low value? Low value is 4 now. You can see here low value is 4. 4 less than equal to high. High is also 4. 4 less than equal to 4, true. So it will come inside the loop. So mid is equal to, what is the low value? Low value is 4 and high value is 4. 4 plus 4, 8 divided by 2. What is 8 divided by 2? 4. Mid value is set as 4. So mid value is set as 4. Now the next condition is key. What is the key? 50. User has given 50. 50 equals to a of 4. What is a of 4? A of 4 is 50. 50 equals to 50, true. 50 equals to 50, true. What will happen? Flag is set to 1. After flag is setting 1, we execute the break. Means we will come out of the loop. Flag is equal to 1. So flag is equal to 1 means what? The search key 50. Now search key is 50. 50 is present at index location. What is the mid value? Mid value is 4. So we found the 50 number at location 4. Right? Now we took the 3 conditions. One case it was available at the mid level. Another value which was available at the lower end of the array, and one value which was available at the higher end of the value. Now we will consider search key is not found. Okay, I will randomly take some value. Let's say user gives some value 33. We started with 33. Let's take 33. User gives us value of 33. Now again we will start. Okay, so user has given the key as 33. We start with the loop again. Okay, low is equal to 0, high is equal to 4. 5 minus 1, 4. 0 is less than equal to 4, true. Mid value is calculated, 0 plus 4 divided by 2. 4 by 2, 2. So mid value, first iteration, mid is set as 2. And after that, key is now 33. 33 equals to a of 2. What is a of 2? 30. 33 equals to 30, no, false. So we don't execute this, we will come here. Key is 33 less than 30, a of 2, a of 2 is 30. 33 less than 30, false. We don't, this statement is not executed, so it will come here. 33 greater than a of 2, that is 30. 33 greater than 30, true. 33 is greater than 30. So low is equal to mid plus 1. Mid is 2, 2 plus 1, 3. Now low is equal to set as mid plus 1, that is 3. Then after that, after this step, it will go to the next iteration. Now what is the value of low? 3. 3 less than equal to 4. Answer is true. It will recalculate the mid value. Mid is equal to 3, low is 3. You can see here low is 3. We are in the second. 3. 3 plus 4 divided by 2, that is 7 by 2. 7 by 2 is 3.5. 0.5 is discarded. We have the value of 3. So mid value will become 3. So now the mid is equal to 3. Next condition. What is key? Key is 33. 33 is equal to a of 3. What is a of 3? A of 3 is 40. 33 not equal to 40. So this statement is not executed. 33 less than a of 3. A of 3 is 40. 33 less than 40 is true. 33 is less than 40. So we set high is equal to mid minus 1. And what is the value of mid? Mid is 3. And we set high as mid is 3. 3 minus 1, 2. So high will become high will become 2. Okay. After that, it goes for the third. Then this statement is 33 less than 40 is true. So it changed the value of high. If this is true, this will never be true. One of these will be true. You can just check it again if you want. 33 greater than a of mid. A of mid is what? A of 3. A of 3 is 40. 33 greater than 40, false. Okay, it will not go here. So it will come to the next iteration. Again mid value is calculated. So what is the new mid value? Low is 3 and high is 2. Okay. So okay, before that we have to check when it goes for the next iteration. Low is less than equal to high. This we must check. Okay. What is low? Low is 3 and what is high? High is 2. 3 less than equal to 2, false. 3 is not less than equal to 2, false. That means it will directly come out of this loop. It will not go inside. When it comes for the third iteration, it will not, this condition will become false. It will not enter the loop. At third iteration, it will not come up. It will exit. Okay, condition false. You can say at condition false. And which condition is false? Condition that is false is low greater than equal to high. This condition, sorry, low less than equal to, not high, low less than equal to, this condition has become false because low is 3, high is 2. 3 less than equal to 2 is false. That is why it will come out of the loop. So when it comes out of the loop, what is the flag value will remain same as what was given initially. So flag was initially set to 0. That value did not change because there was no match. This condition never fulfilled. Okay, this condition never fulfilled. So flag was never set as 1. So when it comes out of the loop, it will check flag is equal to 1. 0 is equal to 1, false. So it will say search key is not present. Okay, so that is how this code gets executed. Okay, next what we will do is we will do the execution and after that we will go through the flow chart. So execution, I am going to use the JDoodle. Okay, already you are aware of the URL. So if you are not aware of the URL, I am going to type it here. This is the URL: https://www.j-doodle.com/c-online-compiler/, or you can use any other. This is a web-based compiler. If you want to use any compiler, you are free to do so. I have given all the details. Whichever is convenient, you can use it. Now what I will do is I will just copy that program and I will paste it. So don't copy and paste. Please always type the program. Just to save some time, I am going to copy the program. Okay, it didn't copy, I think. Okay, it copied. Just quickly I will do the indentation. I don't like to see the code without indentation, so always you should focus on indentation. It makes okay. Now I will indent the while loop. I have the while loop. I will use first level of indentation, and then I have curly brace. Once I start curly brace, second level of indentation. So this is second level of indentation, and again I have curly brace. Then next statement will be third level of indentation. You can see the third level, 1 2 3, and this is 1 2. This belongs to this curly brace belongs to this one, so I will indent it only twice. This is 2 inside open curly brace, 2 indentation. This statement 3 indentation, 2. This is 1 2 1 2 1 2 3 1 2. Okay, and this one belongs to the while loop. So you can see here the line which nicely indicates this is the start of the while loop, this is the end, this is the start, this is the end, this is the start, this is the end, this is the start, this is the end of the block. Okay, this is while block, this is if block, true block. After that here this is the indentation I need. Okay, your code will run fine. There is no issue if you don't do the indentation. Okay, if you don't even, if you write everything in the straight line, the code, if there are no errors, code will perfectly work fine. There are no issues. Only thing, it doesn't look very nice, it doesn't look readable. That is the only problem. Okay, now I have all the code here, and as I said, we have to give the size of the array, then elements. So we are going to give the whatever we just discussed, and also we have to give a search key. So first I will give the standard inputs. I will give 5, and 5 is the number of array elements, size of the array. Then 10 20 30 40 50. Okay, that is it. And first which we will give, we will give 30. Okay, that is the first case we took, and this is how we give standard inputs in this particular compiler. And I will say execute, and the execution happens here. Okay, some issue with the JDoodle. Let me check the internet. Okay, internet is connected. Let me run again. can see the output. Okay, enter the size of the array, it will take 5. Enter the array elements in ascending order, it will take 10, 20, 30, 40, 50. Enter the search key, it will take 30. The search key 30 is present at index location 2. So 0, 1, 2, that is the output. That is what we discussed. And this particular problem, I told you, this is a warning, just a warning. You can see warning. If you want to remove this for integer, we will do that, so that we don't see that in the, just say here int, return type as int. And next execution, we will do again execution. This time we will take the value search key as 20, okay, which is lower than the middle value, and I will run it again and we'll see the, now you can see the search key is key 20 is present at index location 1, 0, 1. So search key is present at index location 1. Next we will take 40 or 50. We did 50, we will take 50. Execute. The search key 50 is present at index location 4. So 50 is present, 0, 1, 2, 3, 4. So it is present at index location 4. Now we will take a value which is not at all present in our array list, that is 33. Okay, you can see the search key is not present. So this is how the compilation happens. Please try to understand the logic, each statement here, then programming becomes very easy. Okay, now next task is we will see the flowchart. Okay, we have the flowchart here. Just I will tile it so that we can see both of them side by side. So this is okay, already I have tiled it. Alright, so I have the program. I will reduce the size little bit so that it is, everything is visible in one side, one half of side. Okay, this also I will reduce little bit, let's say 75. Is that okay? Yeah. Okay, we have lab program. This is the flowchart, and the same this logic has been implemented as a program. If you understand this flowchart perfectly well, then it is same. Whenever you get a doubt in the program, you can refer back to the flowchart, then you will understand what is the flow. Understanding how the instructions are getting executed, what is the flow, is very important. That is the key to understand any kind of a program. So here this is the start of the program, and this is declaration, and we have one initialization, flag is equal to 0. Lab program number 6, binary search flowchart. This is the start. Initialize, flag is equal to 0. Initialize, flag is equal to 0. After that we are going to read the size of the array. Read size of the array. Then we are going to read the complete array from 0 to n-1. Read all array elements. You don't have to put the loop and everything, so we really don't need that. If you just say in this is the input, parallelogram, read all array elements, in a of I, where I is 0 to n-1. Means basically you are saying read a of 0, a of 1, a of 2, a so on, a of n-1. That is what this representation is, with the one single statement. Or if you want to use the loop, you can do so. There is no problem with whatever you want to do. Okay, basically this is the understanding that you are reading the complete array, all the array elements in with this particular diagram. Then once we read the array elements, then we have to read the key. So in the flowchart, what we have, read key. So this read key scanf, that is read key. After reading the key, initialize low is equal to 0, high is equal to n minus. Initialize low is equal to 0, high is equal to n minus 1. Now the if condition. So whatever you are seeing this is the if condition. So we will go here. While low is less than equal to high, means if low is less than equal to high, if answer is true, mid is equal to low plus high divided by 2. So this is, we are calculating this, and after that we are checking if key is equal to a of mid, means if key is equal to mid value, if key is equal to a of mid. If answer is true, we will set the flag is equal to 1 and it will go to B. What is B? B is the indication, this instruction, so it will go to this part, that is the B. It will come in the next page. So once if key is equal to middle value, it will set flag is equal to 1. We come out of this loop, so you don't have to write, this is just for your information. This B is end of while loop, means it will come to an instruction just after the while loop instruction. And let us say this statement is false. If the statement is false, it will come here, that is another if condition. So you can see here, if this condition is false, it is coming to next if condition. If key is less than equal to a of mid, and if answer is true, what we are doing, high is equal to mid minus 1. So we are setting high is equal to mid minus 1. Suppose this condition is false, we will directly come to the next. We don't execute this. You can see, if the condition is false, we will come here and next statement is A. That is the continuation on the next page. Okay, so what is the A? If this condition is false, directly it will come here. That is another condition where we are checking key is greater than A of mid. So we are checking here, key is greater than A of mid. If answer is true, it will come here, low is equal to mid plus 1. If answer is true, low is equal to mid plus 1. If answer is false, if this is false, it will come here. So if it will come here, and after this it will directly go to the next iteration, that is it will go to the next loop, and where it will go, it will check again whether low is equal to high. So it will go to C, and where is C? The C is, it is coming back here. From there, if that condition is false or even after the true, it will come to C. C is what? Low is less than equal to high. Basically it represents the loop. So this represents the loop. Low less than equal to high, low less than equal to high. As long as this condition is true, it will keep on executing these things. There are only two exit conditions. One is this condition is false, it will come out of the loop, that is B. And second exit condition is when key matches the middle value, flag is set to 1, it comes out. So these are the two conditions. So you can see when this condition is false, it will go to B, and this condition is false, it will go to B. And where is B? B will start from this if condition. That's on the next page. Next page, you can see here. So after while loop, what is the after while loop? This is the while loop. We have if condition. If flag is equal to 1, if it is a true, search key is present. If this is condition is true, search key is present. After that it will come and stop. So search key is present, it will display stop. If condition is false, means flag is equal to 0, false, search key is not present, it will come and stop. So this is the flow chart, and all of you must keep on writing the journals as and when we are completing the programs. So go through this program again. If there is any doubt, you can repeat the video until you understand. Copy this flow chart into your journal. So complete the journal this week.